So expected frequency. We've looked at the theoretical probability of events occurring. And like we said, with, say, the chances of getting tails on a coin, we said that the theoretical probability was a half. But that doesn't necessarily happen. There could be events that influence it. The conditions around us might change that. It could actually not be what we expected, even though there are two possible outcomes, or pure random chance might make things come out not in the 50-50 ratio that we expect. And in fact, it's highly unlikely that things will come out dead on 50-50 if there's two possible events. So let me explain that further with an example. With the coin, if I toss the coin twice, I'm sure you've done it before where you've tossed heads twice. And yet we know what should have happened is that we should have got heads once and tails once. That means in relation to these results, a relative probability of getting heads is 1. Going by these results, we only had heads, so there's no chance of getting tails. So we expect the probability, these results are telling us the probability of getting heads is 1. And yet the expected frequency, what we thought would be, we'd expect the results to be 1 heads, 1 tails. I've tossed the coin this time 10 times. And the heads in this case is 4 and the tails is 6. 4 out of 10 is 0.4. 4 times the outcome came up and 10 times I tossed the coin, so 4 divided by 10 is 0.4. And the probability of getting tails from this, it's showing us that if in 10 times we toss a coin, the tails comes up 6 times, the probability is 0.6. So in relation to these results we're getting, what we call relative probability, the relative probability of heads is 0.4. The number of times the heads came up divided by the number of times we actually did the event. Yet the expected frequency was 5. We expected heads to come up 5 times and hence be 0.5 because we think that the probability is 0.5. Now, the key difference between here was that, if you notice in the first one, where we tossed the coin only twice, the relative probability was 1 because we only had heads. In this case, the relative probability is 0.4 because we had it 4 times out of 10. 4 divided by 10 is 0.4. The relative probability is getting closer to the expected, what we expected to see, the 0.5. So this is telling us the more times you carry out an event, the more likely the probability that we get at the end would be true to the actual probability, the theoretical probability. Okay, so this time I toss the coin 100 times and we get 46 heads and 54 tails. So we're expecting to be even closer to the 0.5 mark. Well, 46 times out of 100 will be 0.46, 46 divided by 100. And I don't know why I put 47 here, which should be 54, but 54 divided by 100 is 0.54. Sorry for the correction there. So the relative probability of heads in relation to the results we've got is 0.46, and we expected 0.5. The expected frequency was 50 out of 100. 50 divided by 100 is 0.5. So in this case, we had 46 heads out of 100. That has shown us that the relative probability is 0.46, but the expected frequency was 50, which is 0.5. So we're even closer to 0.5. If I've tossed the coin 1,000 times, then I'm sure we'd be even closer to 0.5, the expected frequency of 500 in that case. So the probability of a car being white is 0.3. Out of 300 cars, what's the expected frequency of the white cars? So what this question is asking is, out of those 300 cars, how many would we expect to see white if the probability of them being white is 0.3? So all I'm going to do is multiply the probability by the number of events that take place, the number of times you see the car, which will be 90. So the expected frequency, how many times you'd expect to see it, is 90 times. So you can calculate the number of times you'd expect to see it, the expected frequency, from the probability of it occurring and the number of times that the event takes place.